All right, we've got one more way that we're going to solve quadratics, and that's with the quadratic formula. Now, the awesome thing about the quadratic formula is it always works. Always, always, always. Square root method only works certain times. Factoring only works certain times. Quadratic formula always works. It's based off completing the square. Completing the square basically puts something in a form where you can use the square root method, even if it starts out kind of gross for that. But the reason that I didn't just teach you the solving by the quadratic formula is it's a little tedious. And sometimes on easy problems, it's like swatting a fly with a jackhammer. But again, it's nice in that it always works no matter what. You don't have to think about factors and all that. You just plug it into the formula and it works. Okay, so the formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. Now, again, this a, b, and c, that comes from that standard form of the quadratic. So before you're ready to do this, you need to make sure that your quadratic is in standard form. Okay, everything on one side, so equals 0, and then x squared, x, and constant term. Okay, so let's give it a shot with this one right here. You'll notice it is not in standard form. So we're going to move all of this over. We're going to do minus 2x. We're going to do minus 5. So we get 3x squared plus 5x minus 2 equals 0. So a is 3. B is 5, C is negative 2. Now, I teach this slightly different than some other teachers. I suggest when you're kind of doing this by hand / with a calculator, that you start off with this bit under the square root. This is called the discriminant. It's a useful piece of information anyway, but I like starting there so we don't have to write quite so much. So let's start with b squared minus 4ac. So b squared minus 4ac. So 25 minus negative 24. This winds up being 49. And we take the square root of our discriminant, and we get 7. Okay, so now our quadratic formula becomes a lot easier. So x equals negative b, so negative 5, plus or minus, and all of this has already been worked out. So we just say 7 all over 2a. So negative 5 plus or minus 7 over 6. Now, we could leave that as our answer, but that's not really simplified because we can do this addition and subtraction. So this gives us 2 solutions. Negative 5 plus 7 over 6. It's 2/6 or 1/3. Negative 5 minus 7 over 6. So this is negative 12 over 6, which is negative 2. So those are our 2 solutions. Our solutions won't usually be that pretty, but in this case, they are. This is something we could have done by factoring if we had wanted to. All right, before we go any further, I want to talk a little bit about the discriminant and kind of what it means and why we kind of hone in on it. So remember, the discriminant is this guy right here in our quadratic. That's right after that plus and minus. So let's think about what's going to happen if our discriminant is 0. Well, if the discriminant is 0, then we can basically cover all of this up right here. And all we're left with is negative b over 2a. So instead of getting 2 solutions, we're only going to get 1 solution. Okay, just negative b over 2a will be our solution. So if our discriminant is ever 0, then it's going to be 1 real solution. If it's positive here, we're going to have two solutions. And whenever we take that square root, it's going to get us a real number. So we're going to get two real solutions. But what if this guy is less than 0? What if it's negative? Well, when we take the square root, what happens when we take the square root of a negative number? Well, that's going to be an imaginary number. So we're going to wind up with two complex solutions. Complex in that it will contain an imaginary part. So that way, you should kind of know what to expect without diving all the way in. So here's our second example. Now, this is an example that we could not have done by factoring. If you tried to factor this out, you'd bang your head against the wall for a while, it wouldn't work. So we're going to use our quadratic formula. A is 1, B is 6, and C is negative 12. Again, I'm going to go ahead and start with the discriminant. B squared minus 4AC. So we get 36 minus negative 48. So this is going to be addition here. And we get what? 84. Okay, so based on what we learned, okay, it's greater than 0, so we're going to have two real solutions. So let's go ahead and take the square root of this. So 2 and 42, 2 and 21, 3 and 7. Okay, so 2 squared, we take the square root, we get 2. 3 times 7 is 21. Now the good news is we did all of that, so now it's negative b plus or minus 2 times 1. Okay, we did all of the hard work already. Now, in this case, we can divide both of these by 2. We can kind of distribute that division there. And this is our solution. Negative 3 plus square root of 21 and negative 3 minus square root of 21. That's our simplified answer here. Now, obviously, at any point here, we could have shoved this in a calculator to get a decimal answer, but this is the exact answer. All right, we're going to do one more real quick. So again, this one is not in standard form, so we need to move this over. 2x squared minus 3x. Then we have to subtract 5 on both sides. So now it's in standard form, and we can shove it in our quadratic equation. Again, I'm going to start with the discriminant. So negative 3 squared minus 4ac. B squared minus 4ac. Be careful here. Make sure you put this in parentheses, especially if you're typing it in a calculator. Negative 3 squared should be positive 9. If you're getting negative 9, it's because you're leaving those parentheses off. So 9, so 20 should be 80. And we get negative 71. Okay, now negative 71, because we are going to be taking the square root of a negative, we know we're going to wind up with two complex solutions. So we take the square root, we get negative 1 times 71. I believe 71 is prime. So this is just going to be I times square root of 71. And now we can shove the rest of the equation in here. Negative b, so negative 3, plus or minus all of this, all over 2 times 2. And that's basically done. If it forces you to split it up into two solutions, we can say 3 plus I square root of 71 over 4, and 3 minus I square root of 71 over 4. And those are going to be your two solutions.